Hello, today we are going to be doing three-dimensional trigonometry. So instead of having 2D shapes like our triangles or our rectangles or whatever we've been dealing with before, we're now going to have a sketch of a three-dimensional object, and we're going to need to break that 3D sketch down into two-dimensional shapes again, because we do maths in 2 dimensions at Leaving Cert level. So there's no circumstance where we are going to be dealing directly with our 3D picture. The skill in these questions is going to be taking our 3D sketch and breaking it down into 2D parts, into sketches of triangles and squares and rectangles that we're more familiar with. That is the skill here. There's no new maths today. If we're dealing with right-angle triangles, we're going to be dealing with sine, cos, and tan and Pythagoras. And if we're dealing with non-right angle triangles, we're going to be dealing with the sine rule and the cosine rule. So if we see questions like this, we're opening up our log tables and we have all of our formulas available to us. Now, one of the other things about these questions is the language that can sometimes be used. And the first two I'm going to mention in here we may have already come across before. The angle of depression is if you start off with a horizontal line and you drop down from the horizontal. That's called the angle of depression. Depression, you are going down, like a depression in the ground. An angle of elevation is where you start at the horizontal and then you go up from the horizontal, and you are elevated, you are going upward. So an angle of elevation is going up from the horizontal, an angle of depression is going down from the horizontal. And you need to know that without any further context in an exam. The final warning before we get into a question is it's very easy when you are looking at 3D sketches to go, well, that looks like a right angle, and put a right angle in where it isn't justified. The only time we can say we've got right angle triangles in terms of drawing our 2D sketches is where it gives us that information in the question, or it gives us that information in the picture, like we can see next to our S point here on the left of our screen. So if they don't tell us we've got a right angle triangle, we cannot assume it. But they can give us the fact that it's a right angle triangle in slightly obscure ways. For instance, a very common one, if they give us a physical situation like they have in this question, ST is a vertical pole and PQ, R, and S are the 4 vertices of a square in a horizontal plane. Well, if they've told us that the ST pole is vertical and the square, the blue square here, is horizontal, that means that there is a right angle between ST and all of our other points going out across the blue square. If this is vertical and these are horizontally away from S, that means that we have right angles. So we have a right angle that they've drawn in for us, and we also have a right angle going down here. We also have a right angle going across for the triangle that's kind of sticking out towards us from the page. So we need to be able to spot where we've got our right angles in our diagrams. That's a key thing because it means what tools am I using? Am I using sine, cos, tan, and Pythagoras, or am I using the sine rule and the cosine rule? And if I can figure out those things and draw my diagrams accurately with right angles in the right places, then these questions are very much the same as what we've already tackled. Now, let's have a look at it in practice. So we've read our introductory pieces of information, and we know we've got a vertical pole and horizontal ground going away from it. And we are told that the angle S or T, S or to T, so we start at S, go to or, go up to T, that's 60 degrees. And we know that OR-T, or to T, the distance, those parallel lines mean the distance or the length of between our 2 points or and T is 20 meters. And we're given both of those pieces of information in the question. You're not necessarily given all of the information in the English in the picture. So make sure that you are carefully reading all the English you're given to clarify for yourself what information you've got and fill it in on the diagram. The sketches are huge in these questions. They're the main thing that decides whether we can do them or not. So let's have a look at part A. We're asked for S or. So the distance between S and or parallel lines mean distance. So we're looking for this distance here. Well, what shapes have I got that allow me to see, that include, I should say, that allow me to get information on S and OR? Well, I have this big triangle here that I'm able to draw in. So I draw a separate sketch now to keep track of what information I've given. I have this triangle here, ST OR. Why am I drawing this in? Because it has the side I'm looking for. So I'm going to draw any shapes I can see that include the shape that I am looking for. So I'm looking for this length SOR, so I'm going to call it X, because it gets cumbersome rewriting SOR all over the place. So I'm just going to call this distance here that I'm looking for X. Now I know that this angle is 60 degrees, and I know that that distance is 20 meters. This is given to me in the question. So this is my triangle going here, and I have to be able to break out that triangle and place it as this is what I mean by a 2D diagram, and we make sure that we write in the vertices. Keep your vertices labeled, because these questions tend to build on each other, and we need to be able to keep track of what information we get from each part of the question. Now, there is another part that gives us information about SOR, so I should write that down as well. The square that's a horizontal piece, S, or the side I'm looking for, and PQ. And I have a line going between those two. Do I know anything else about this shape? Well, if I know that this is a square here, and I know that this is a diagonal on the square, I know automatically that this is 45 degrees here and here. But I don't know anything else about it at the moment. But I do know that they're 45 degrees because they're diagonal on a square, so they're going to bisect my angles here. Now, that's all of the information that I can see involving S and OR, so that's my X as well. Now, what shape have I got more information on? Well, I know that this is 60 degrees and this is 20 meters, and I should also write in that I know that that's a right angle. It's given to me in the picture, and it's also told to me because this is vertical and this is horizontal. Now, I have all of the information that I need because I recognize I've got a right angle triangle here. I'm looking for the adjacent to the 60-degree angle, and I have the hypotenuse of this triangle. So I know that at cos of 60 is going to be the adjacent over the hypotenuse. It's going to be x all over 20. Multiply both sides by 20 to rearrange the formula. And I get x is equal to 20 cos of 60. I can throw all of that into my calculator, and I just get 10. And I don't forget that I'm talking about meters, so that's S, or it's a very good habit to rewrite at the end what you were actually finding. So my X is just a placeholder because rewriting SR all the time is a nuisance. So I called SR X. So this is my answer for part A. SR is 10 meters. What's the last thing I do? I'm going to fill that information in on my picture. So I know that X now is 10 meters. And I know that X here is 10 meters. I have no idea what I'm doing next, but I actually have a lot more I can fill in on this diagram now, because I now know that I have a square here. So if this length SR is 10 meters, and this length is 10 meters, this length is 10 meters, and this length is 10 meters, because they are, because it is a square. I'm told that this is a square in my question. And if you like, if you're able to keep it neat enough, you can write on your original diagram as well, but you need to be conscious that it doesn't get too muddled with all of your writing. Writing it out as separate pictures is the real skill we need, so it's often a good idea to just keep your drawing to a minimum on the original document. But there's no problem with putting in 10 meters, 10 meters, and so on as you are going around. It can help you keep track of what you've got. Just make sure that it doesn't get too messy. Now, part B, we want to know the distance ST. Where's ST? ST is our vertical pole. So ST is our vertical that we've got here. We already have a diagram of this situation where we have loads of information already. So let's just use a different color here. I want to find ST. I'm going to call ST Y. So let's write that in as a note here. ST is going to be Y. And that's what I'm looking for here. So I know 20 meters and I know an angle of 60, so I can just use, and it's a right angle triangle, so I can just use sine because the opposite over the hypotenuse for my 60. So sine of 60 is going to be the opposite over the hypotenuse. Almost identical question to the last time. We're just now looking for the opposite side of our right angle triangle. Multiply both sides by 20. And I will have y is equal to 20 sine of 60, which I put in my calculator. And I've left it in surd form here. You could write it as a decimal, but if they give you a surd out of the calculator, it's a lot neater to write than carrying around an awkward decimal. And I remember that I have meters, and it's ST is what I've just found. Now, it's worth pointing out, I have two sides of a right angle triangle. I want to find the third. I could have just as easily, so this is a side note, I don't need to do this twice, but as an aside, I would know that 20 squared is equal to 10 squared plus y squared. That would be a perfectly valid way of doing this question. There is no problem with that, and you will get exactly the same thing. You're going to get that y is equal to 10 root 3 meters. So this is an aside. You could have just as easily used Pythagoras, and I know that because I'm looking at a right angle triangle. What tools have I got available to me? It's sine, cos, and tan, and Pythagoras. Now, next point, SQ. Or is there anything that I just found that I should fill in? Yeah, I have, that's 10 root 3 meters. SQ. So SQ, do I have a diagram including SQ? I do. So my diagram here of my square has SQ in it, and I actually have enough information to find SQ immediately. As we used sine and cos several times here, I'm going to do Pythagoras this time. I can see that SQ, I'm going to call it H for the hypotenuse. SQ is the diagonal of my square. So I'm going to call it H, and I can see that H squared is equal to 10 squared plus 10 squared. H squared is equal to 200 squared. Sorry, 200, I should say. I get the square root of both sides. I don't need to worry about the negative of this because H is a length, so I don't need to worry about plus or minus here as I often would. So I just end up with 10 root 2. So that ends up being 10 root 2. So I've now filled that information in everywhere. And what's my last point that I'm looking for? QT. I don't have a diagram already for QT, so let's go back to our original picture. QT is our diagonal that's kind of coming out of the page at us this way. So I need to draw this triangle. Is it a right angle triangle? Yes, because